Okay, so I think we're ready to pick up with Scania now, so we get some real life now, what happens in DevOps. Okay, guys.
Thank you. Hi everyone. I guess you hear me, but as said earlier, hope you understand me as well. We are two engineers from Scania. I know, probably you know where Södertälje is, probably not, but it's very close to Stockholm in Sweden. We will not talk anything actually about that hardware that is rolling on the roads. We will catch up on this DevOps topic that was discussed earlier. And first of all, thank you, Perforce, for letting us be here. Perforce is helping us to achieve continuous delivery for version control. But also we have had a lot of ideas from Perforce, the way they work themselves, but also this, what was the article? The new way of working.
The new normal.
Continuously deliver the new normal back in 2013, I think. It's a still going strong article, and I could encourage you to read it. My name is Anders. According to this picture, I'm working the dev side of Scania. I will call myself a developer in this topic, but more like an architect that have the right to code, more or less.
Yes, hello, my name is Mattias. I represent operations part of Scania right now, and I've spent around 12 or 13 years within Scania IT's infrastructure and operations department. And I started off as a technician and have various positions since then, and since like 3 years back I'm a manager for one of the infrastructure teams at Scania IT.
These are mostly if you Google DevOps, you get about 2 or 3 of these pictures. And it's a traditional throw-at-the-wall picture. Perhaps everyone has seen that. Or this works in dev. It's also a problem now when we have tossed that code into a production environment. And also this tug of war that actually Scania has invented. DevOps, all things. We will take a more practical view of what Scania think of DevOps. And we are only 2 engineers of many that talks about Scania, so we have a hard time to give a perfect view of what Scania thinks, but we'll do it from our own perspective. So the first disclaimer is that the opinions we express here is from our own experience within Scania, but also in previously work. And the next disclaimer is that the tools, we will show a lot of tools here. Scania does not value the tools more than those not mentioned, but of course with one exception.
Okay, who here knows, first of all, that's what Scania does? The first picture maybe, kind of, a few of you. So then maybe you don't know Scania IT that much. But just to give you some kind of perspective of how big or small we are, we've got some numbers. We are around 1,200 workers, have a portfolio of around 1,400 applications. We have a lot of servers, a lot of data. We have our main site in Södertälje in Sweden, and we also have a regional site in Brazil. And Scania is a global company, so Scania IT supports Scania on a global scale. And also, it might be interesting to know that we deliver most of the IT that you can deliver. Not much is outsourced. We have our own data centers, for example. We deliver the whole hosting kind of infrastructure stack. And we buy applications and we build applications. And we asked our guy responsible for the implementation of Perforce at Scania to give us some numbers. Also, just to give you a perspective, if we're big or small customers, and we would argue that we are a quite big customer using Perforce.
Okay, take that one. I think the previous session talked a little bit about agile, and we will catch up with that term as well, because I've seen that discussions about DevOps, first of all, will motivate by developer or feature teams that work with agile methodologies for about a decade or perhaps more. even since the Agile Manifesto was invented about 15 years ago. And all these Agile pictures are one process that is skipped down into a circle. So here's another circle. This engineer wakes up in the morning, he gets an idea about change. Probably in this case, it's a small change that he wants to make, or she wants to make, on the system. He tested it and coded it. Of course, he tested it because he or she works with testing and development, so he made the test first. Then after lunch, he does a production deploy of the change. Probably there will be some kind of test deploy before that and so on. And perhaps the same day, or at least the next day, he could evaluate through metrics if the outcome of that change was good or bad. And the outcome is measured by value from the customer feedback in various ways. And when we look at this picture, one might think that this could apply to a small, this term lean startup company. But actually, we have engineers, at least some of them today at Scania, that can work in this environment, even though we are about over 1,000 of engineers. We come down much to the idea of autonomous teams that we can work from idea to verification of a change. If you take DevOps in this picture, we have two parts. We have the trust of the engineer, that he or she can get ideas himself. Even if you are only a code monkey, you can get good ideas of refactorings or performance changes and so on. You don't need to have a tie to get ideas. But also, to enable this, to not throw out bad things in production, we also need automation and good testing framework to enable this type of working. I like this picture. It shows that a developer have a really hard time in waterfall projects to handle different states of code. At the right, we have discussions in our backlog to produce new features. We have this pending code state. That's the time when we have checked in code, but the code is not live in production yet. And of course, we have production code that is executing, and that's where we get our money from our customers. And one good thing is that we hopefully someday delete code that is not giving any value for the customer. So the hard part here is the pending code. The more pending code that is stacked up before it's going to production, the more distance that the developer or engineer will get to that change, and that will start to, you saw that train in the last presentation, that will make these big production outages. And the value here, we can argue deleted code is value or not. But I think that deleted code is really value for the end customers, because that enables us to produce more code and maintain code that really gives value, and not maintaining code that is only being in production and have it working. For sure, I've seen some of these similar slides before, but this is actually the reason for Agile. This was a study about over 10 years ago, but it shows that if we work in waterfall type of working, we tend to deploy more code to the production environment that is not in use, or at least rarely used, that is actually giving this value. So this is the motivator of tight iterations and all these cycles that Agile development shows. I won't talk so much about waterfall. I'm pretty sure everyone has worked in that way and trying to at least get away from it. But this is some kind of ladder that when teams are doing this Agile transformation, they start to do Scrum. That's a good way of cutting off some of these stairs. We get testers and developers working tightly together. That's really good. At least for us, we have seen that this has improved our way of dealing with the bugs and so on. But in this world of at least enterprises, when you have these developer and operation silos, the operations guys over there are still in the last step. And this makes this ability to have a complete cycle time nearly the same way as in the waterfall way of working. Sometimes we also have a stair to the left, and that means we do not really have time to evaluate with the end customer if our changes was valuable or not. So when I know for sure you have heard the Water-Scrum-Fall term before. But DevOps, we're starting to closing up the DevOps. DevOps is the way, the extension of Agile that we focus on clearing the wall on the right side. And we think that if we tear that wall, we also will enable this total feedback cycle. To motivate DevOps practices, we have to work with continuous integration practices as well. That was also shown on the last presentation. And this is pretty much a shortening of what we think integration is. First of all, version everything. I will catch up on that one. Automation, automate every manual steps. Everyone work on main branch. That was the major thing we missed about 5 years ago when we thought we were doing continuous integration. One can create feature branches, yes, but those should be synchronized to the main branch on a daily basis. Quality over new features, and that's the reason for the picture in the middle. These are lights that we have in the ceiling in the office, and when an integration test or a unit test or a build failure, perhaps a production deployment goes bad, the red light goes off. And then there should be a very short time before that one gets yellow. And when the light gets yellow, that's when someone in the team that is responsible for this pipeline is working on the problem. And then the lamp can be green, yellow for minutes, perhaps even hours, not days, but it's okay to have a problem, but it's not okay to ignore it. And that's the reason for the text. We should not continue to do features that we have estimated in sprint planning meeting before handling with these errors that occurs in our daily work. That's super important. If the red light is lit about 3 minutes, then we have a signal in the office, and that's tend to give a more attention. That's a little tip. This is actually the most valuable slide for me when we hire new people or when we're taking in consultants. We take a discussion about this picture. And this is an engineer that works with version control, checking code at least once a day. That's a good practice for continuous integration. We should version everything. Code, test, operations, that probably often has been made by all of us for the last decade or so. For technical reasons, the databases has shown to us to be the hard thing to manage. You really need a tool, we saw DB Maestro here, to handle your database changes. At least very important, we have relational databases. You cannot only toss them into Perforce and then they are versioned. That's not. You cannot create a reliable deployment pipeline without having some kind of tooling for that. Infrastructure is the hardest part. I'll show the coming servers here. For us, infrastructure is still to be made to have a good versioning of. We have started with it, but to being able to fire up new web servers, the database servers, and so on, that should also be in the version control. And I said this was the most important picture for new developers. And the first part is, when you came to Scania, at least Connected Services, that is my department, you are not hired as a developer, or you're not hired as a tester. You're an engineer. Perhaps you have developer skills or testing skills, But you will not, as a developer, have any person to the right of the version control. You don't have any manual person that will set a quality stamp on your code. You will get the person, if it's an operation person, a testing skilled person, you will have a code review of what to do. And you will have the deployment pipeline, the continuous integration server. We heard Jenkins and Sia Jetways showed as well. TeamCity has a continuous integration tool to run this automated test and so on. We have a deploy server for our, at least our .NET development, and so on. So to the right of the Perforce, we don't have any manual steps. And if you as an engineer feel that's uncomfortable, probably you're not the person that should be in this type of working, at least not yet. But if you feel it's tempting, or it probably could work, because I have written some unit tests, then this environment is, I think it's a good way of working. One slide before we go into DevOps, more DevOps specific discussions. Software delivery through the decades. In the 90s, programmer acts much more like a code monkey. He produces code. And when the Agile Manifesto arises, when the testing frameworks came along, the programmer was grown a little bit to a developer, but also wrote some tests. And I think over the last decade, most developers could manage Jenkins or TeamCity to handle the automation or execution of build and tests. But today, our feature teams will not only be responsible for the quality of the test or the code, people must also provide this deployment pipeline, the automation to be able to maintain this application in the future. So that the scope for what a software delivery has been bigger.
Okay. Thank you. I'm going to try to look into more of an organizational aspect of DevOps. This picture represents Scania IT in the sense that the feature teams there represents our development department, and the lower box, the black box, is the infrastructure and operation team or department. And I think this is quite a traditional setup in large enterprises. And then you see IAAT. It means infrastructure as a ticket, which means the communication between the development department and the infrastructure and operations departments is mainly based on ticket-based communication. So we talk via tickets. Since this has been working for quite some time. I wouldn't say it's been a bad division of the responsibilities, but given the agile transformation that has taken place mainly within the development department, we have proven to become the bottleneck, which keynote speaker had also talked about. So we realized that this is not really working. So we want to do some kind of transformation. What we want to do is to move operational capabilities from our infrastructure and operations department into the development teams. And also by doing that, making the interfaces much clearer, or the responsibilities of the infrastructure department much clearer, and exposing our infrastructure services as actual services that can be consumed via maybe some API or so. The nirvana of what we would try to achieve is some kind of autonomous teams that have the end-to-end responsibility of what they make. So that's why we think moving operational capabilities into these development teams is a good way to go. Because then we're also moving the operational responsibilities to those teams. And Then we have a principle here that says you build it, you run it. Or we didn't say that it was the Amazon guy. And we also want, as I said in the previous picture, our infrastructure services to be consumed or be used as, or version controlled as code. That's what we're aiming for. We wouldn't say we're necessarily there yet.
And this is a little bit more practical view of your last slide, Mattias.
Yeah.
This is this could be me in the past. I need a new website or new server. I made this infrastructure as a ticket via telephone, Jira, or some other ticket-based systems. Probably it was via mail or instant messaging, because I tend to know the network guy that does this load balancer tweaks and or so on. But the movement we like to be, and the way of working with cross-functional teams, I still really need that operation guy. But I want the operation guy with that competence to be close to me, to sit down and see, now we're going to do, in this case, a new website. How can we write the code to reliably reproduce that one in a test environment, or a staging or a production environment, or perhaps also scale up this in the future when we get more customers. And then we collaborate on how to consume these APIs that Mattias talked about in the last picture. And then we check that one in these lines of code into the version control, and that later on can be executed in the continuous deployment pipeline.
Okay, so drilling down the organizational chart a little bit to show the transformation that we have been doing and that we are about to do. On the top, you see .NET, Java, and Oracle. That represents our development department. They are organized in technical towers, we call it. You have all the .NET developers in one place, and Java in one place, and Oracle in another place. And then you have a classical kind of infrastructure technical stack. You have the data center with the network, storage, hardware virtualization, operating system and database, application service and web service, and so on. And this is actually also a picture of how we are organized. We are organized in function silos. So we have an actual team or a group that works with operating systems and databases and so on. And the guys on the right-hand side shows this is actually a picture from maybe a year back, how it looked back then. So we had a service responsible and some kind of technical responsible for each of these silos. And they were delivering their component or service, you might say, to the right. So you created a database service or operating system service and so on. The problem with this, though, is that our developers do not want to consume those kind of services. This is actually just components. They want some kind of hosting services. So it didn't really work. So we did a change around a year back, and we tried to shift the focus. So it took away the service responsibles and the technical responsibles, delivering components. And we said, okay, let's deliver services. So we now we have an infrastructure architect and a service owner that is responsible for the whole delivery for the .NET kind of hosting services, and another couple for the Java and so on. So it's much clearer for our development department. They have one point of contact in to the infrastructure and operations teams, and also we are thinking of services as how the developers want to consume them. So it's much more kind of customer focus right now. This was the first step. We are still, the technical competence are still kind of in those teams. So there are still issues to overcome. But this was the first step. It's more of a mindset change. And we chose to throw in this picture as well. I don't know how much sense it makes try to explain. When we have been organized as we have in technical silos, one of the main reasons is to optimize the resource utilization, because it makes economical sense. But what this graph shows is that if you utilize your resources 100%, the result is an extremely long waiting time or lead time for deliveries. So we also have kind of a clear statement now that we want to focus more on optimizing the flow rather than the resources. This will mean, a less resource utilization. You have to be aware of that, but it doesn't necessarily mean lower throughput. We would argue, or at least think, that this will lead to better throughput and effectiveness over time. Does this make sense? Do you see this at all in the back?
Lean thinking, basically.
Yeah, exactly. Exactly. There are different pictures showing kind of the exact same thing. But we wanted to throw this in because we have been, since I've been at the operations department so long, I know that we are very optimized from a resource perspective. And well, 2-3 years back, that kind of shifted.
Yeah. When you are on a big company like Scania and a product that has been shown to be successful, it tends to grow by the time. The code base grows, and for sure, we talked about earlier, we try to delete code that does not give any value, but many of us for sure have ended up in some kind of monolithic application that is hard to change and so on. That's pretty much what this picture will show us. And this is another view with more architectural view, that perhaps in the past, when we have a high attention on architecture, we made components inside our applications that have certain responsibilities and so on. But often monolithic applications have one thing, that they often have one big database that many components rely on. And that makes, in our case, we have a vehicle table, strange on a vehicle company, and that table has a lot of joins towards it. So the moment we need to be faster, even though we're doing this continuous integration and focus on continuous quality, when we have grown over 15 engineers on our code base, this is for one of our applications, we see that to be more agile and to react more on customer feedback, we need to split this into several parts. And so the new picture, some kind of this is the same application for the end user, but it has been split into one or more services per feature team. So the feature team can, in this case, be more autonomous and do changes from top to bottom and do a production deploy without having a dependency on another service. And when I say dependency, of course, these could have SOA integrations, often RESTful APIs these days. But so that's a dependence as well. But they're not dependent on doing a change or a production deploy of their own services. And for doing this transformation, we can't have infrastructure as a ticket anymore. We need to, you see at the bottom, we have all the infra needs as well. We need monitoring, we need load balancing, we need a server, database. And if I have these manual steps to create all these, for the monolithic application, we could have manual steps because we didn't do it so often. But when we split on applications, we really need to wrap up this type of work. I really like this picture. It's from Amazon, but it's a good view over some kind of system. But it's more or less the text and the number that really have an effect on me. But this is very much about configuration management. If your data center burns down, if you have versioned the code to reproduce that environment, even if it's a web server, a database server, a load balancer, firewall setting, and so on, that should be reproducible from version control. Of course, you somewhere need a new data center and hardware to apply it on. That's for sure you need to have. But you should not have all these 15 engineers fiddling around with configuration changes and so on. It should be one click to spin up the new environment, even if it's a test environment or a production environment. How many of you know the unique number of 11.6? Often there's at least one. When we're talking about Amazon, I think those are the company that has proven to be the most iterative way of working in terms of production deploys. These are the number of seconds between, on average, the production deploy on Amazon services. We are not really there yet, but we are closing up. How many developers are here? Or engineers? Yeah, some of my learnings, and I encourage you to give your top five of your learnings through what you have in your from your experience. You can't be a code monkey anymore. You really need to see you need to know some part of the domain that you are making system or doing the code for, to be able to have new ideas. Because you as a developer or an engineer are really specific in the way that you can see small things in your daily work that could be even a huge impact on the end customer experience. UX guys and product owners for sure are really important as well to gather feedback. But they don't really know that these small changes are really easy to do, and that could be a good hypothesis for doing a small test and evaluate if you could roll that out to a bigger audience. So learn your domain. It is also more fun to realize that this code I'm written is used by a real person, or perhaps, in my case, several thousand persons on a daily basis. Learn to work on track. I have no time to dig deeper into that, but learn to work on track on mainline. We have 15 engineers that work on track. We are not Google size, but they are more than 1,000 engineers doing that, so it is absolutely doable. For us, this light in the ceiling has shown to be one good way of keeping up this pace in dealing with quality. Do not rely on database backups when you're doing your data development. Version your database so you with one click can reproduce a developer environment when you can sit on an airplane and you can have a local database, your local business logic in Java or C# or whatever, and you can work in that little silo for doing most of your work. And that type of versioning can also, of course, be used later on when you're doing automatic deployments to staging and production environments. Never blame bad code. When we are working with monoliths, it tends to, when a new developer comes in, he sees that there's 32% coverage on this code. I don't really want to touch it. But the reason for that code was that for 10 years, when this code was written, and Unix frameworks didn't exist. So really don't blame bad code. I have had times when I have blamed a code, and then later on, when I looked into Perforce, the trace of this, I realized that it was me that wrote that. It's really true. So blaming bad code will for sure not give value for end customers. We can have a discussion on how to improve it, of course. Ops guys are not purely evil persons, even though it takes a long time for you to do this infrastructure as ticket. I think Mattias looks like a quite handy person, and for sure he is as well. avoid hero-based culture. I think this will be our last couple of slides. This is a guy that always needs to be in place when we have a production deploy or when we have an outage or something. And from his desk is a line of persons that want his help or her help. This guy is actually a really good person. You should really try to maintain this person in the company. But he's one of the biggest obstacles for us to be agile or do DevOps practices. And why? Yeah, that is because he often doesn't version his work. He is that very important person because he has those configuration changes in his head, and he knows what servers we're being to, and so on. And those are, he's often he works 60 hours a week, and it's very good for the company. And here's the book that we saw in the introduction. That's a really good book. I forced Mattias to read it. You should try to get managers as high up in the organization as possible to read this book. But even for me as a developer, it was a really good book to read. If you want more technical details about how to do continuous delivery, for sure, Jas Handel's continuous delivery book is about 5 years ago and still going strong. But this is a more, I think this is a novel in some sense. So when a real hero quits the company should only continue to flow. So this guy, I don't think you see it, but this guy, he left the company, he throws his things that he had made, and the other guys can just continue to work. And this throwaway is not a bunch of documents in this box. It is code, test, configurations, infrastructure configurations that is remaining in the version control. So our last word is version for the things.
Thank you. Probably need to keep on track. So I think if it's okay, we'll take some more questions over coffees, and I'm sure you'll be very busy drinking coffee. Talking to the folks here. Yeah, just like to thank you for your presentation and for Michael's this morning as well. And we'll go and take coffee. Come back in 30 minutes. That'd be great. Thank you.